Hey, guess what, everybody? This is Gardner, the Linux Gamer. At least that's the name of your channel.
Right.
The Linux Gamer. That's how I read it. It's like, I'm the Linux Gamer. Seems
right.
I mean,
I've gotten some flack for that. It comes from the fact that I'm not very good at naming things.
Yeah, we're terrible at naming things. Our news show's still named The News.
Right. If I had a kid, I'd name it The Child.
That'll give them a complex, as it turns out.
Yeah, probably. Narcissism.
The child is displeased with this. So the goal is to build you a machine. But so you asked, like, what's the best kind of machine to build? And it's like, what do you want to do? And you told me, and it's like, well, I don't know off the top of my head how those programs behave. Kdenlive mainly, but also some gaming. Mm-hmm. So I thought, well, we've got the hardware. Why don't we just do the experiments and actually try to figure it out? Because having used Kdenlive myself for this channel and a whole bunch of other stuff, it's a very temperamental program. It has differences between like the Fedora version versus the Snap version versus Ubuntu. It has a mind of its own, and it doesn't like every system necessarily.
That's quite true. That's been my experience with it, and as we found out, like there's not a lot of repeatability with the testing that we
not
tried.
Super optimized either.
Right, but it was a lot of fun to figure out some new things about software that I use almost every single day, especially on my channel.
I need this software to make a living. We've got to take it apart and figure out how it works, and can we make it better?
Kdenlive developers, if you guys started a Patreon, I would totally donate to that. That would be great.
That would probably be a good idea. Most open source developers, they need to do things like that. They need people like us to evangelize their work so that people can be excited about them. We did that with Looking Glass, which is the thing that lets you connect to your Windows virtual machine's graphics card virtually. And we just helped evangelize that, and that helped the project tremendously, I think. And so, Kdenlive developers, anybody else, you want to do stuff with level 1? Open invitation.
Yeah, and for those of you not in the know, Kdenlive is like the video editor for Linux, and it's really, really good. I love it.
Actually, DaVinci Resolve, and it's like, Kdenlive is really good. It's fully open source, unlike DaVinci Resolve and a lot of the other programs. There are other video editors, of course. Yeah. Yes, we're aware of Blender.
Oh my God, yeah. And there's also OpenShot and a couple other ones, but in terms of
having used all of them, Kdenlive.
Yeah, absolutely.
Although Chris is really fond of Blender, as it turns out. Blender is scratching some sort of Lovecraftian itch that she has.
I've never heard it described as Lovecraftian, but I think that is precisely the way to describe it.
We seem to have strayed somewhat from our topic.
Oh, well. That happens when I'm around.
So, the systems that we tested, let's get a rundown of those. Threadripper, 12 and 16 cores. Mm-hmm. The Intel i9 7900X, that's the $1,000 10-core CPU. And these are as close as we could get in configuration, 16 to 32 gigabytes of RAM. I think most of the systems had 32 gigabytes of RAM. Yep. The Intel i7 8700K overclocked to a modest 4.5 gigahertz with a closed-loop water cooler. We also did a garbage build. We did two variations on a garbage build. A dual-socket Xeon, socket 2011, that's the E5 2620s. 6 cores, 12 threads, 2.5 gigahertz. And also a single Xeon E5 2680 V2. So that's a 10-core. And that was running at 3.6 gigahertz. I think 3.6 gigahertz. Because we were using the Asus multi-core enhancement with our Z9 PE motherboard, which is a great socket 2011, original socket 2011 from 5 years ago motherboard. And the results with Kdenlive were actually unpredictable.
Yeah, they definitely were. So we started out with the garbage builds.
Yeah, the 2620. Dual 12 cores, 24 threads across 2 sockets, 64 gigs of DDR3 memory.
The first garbage build that we did, actually, let's talk about what we actually did for.
Okay.
So the way we tested this was we had a solid-state SATA drive set up, and we had Ubuntu installed on that, and then we had Kdenlive and a project file on the IO drive 2, which is
Yeah, the IO Drive 2 is an enterprise grade SSD from a long time ago, but you can get them on eBay for around $300, 1.2 terabytes, read speed of 2.5-ish gigabytes per second, write speed of about 1.2 gigabytes per second. You can do massive IOPS with these. So if you need a lot of random IO, you've got 20, 30 threads reading parallel, reading your multi-gigabyte video file to operate on it in a parallel fashion. That's the drive that will help you do that. Although it turns out Kdenlive doesn't care.
Yeah, it's basically single-threaded.
Kdenlive's like, I can run 20 threads on this drive without bogging down. That's great.
Yeah, one at a time, please. So what we ended up doing was we filmed a clip in 4K, and I'm not editing in 4K yet, but
4K
I want to.
30.
4K 30, right?
We also did 4K 60 10-bit, and it chugged. So we're like, you know what? Let's just stick with 4K 30.
So the one thing that did utilize all the cores well was transcoding, and because we couldn't edit in 4K
on any system,
we ended up transcoding all of our files to proxy clips. And that was one of the things that we used as a benchmark because we timed each job, right?
Yeah.
And then the other thing that we did was we rendered an edited version which did color correction and it did like some transforms, just for like real use case scenarios. So
in a nutshell, the transcoding thing parallelized great. The more cores, the faster the cores were, it would use everything. But the project settings would parallelize a little bit, but it was really sketchy and random.
Yeah, it became somewhat of a nightmare. So the first garbage build that we did, didn't
work so good.
It didn't work great. It was definitely the slowest. When we were transcoding proxy clips, we ended up with 2 minutes and 16 seconds for the total time it took. And that was a 3-minute clip.
Yeah, and that was, 2 gigahertz. It's also when we noticed that it wasn't turboing correctly to 2.5 gigahertz. It was just 2 gigahertz across the board.
Yeah. We ended up not finishing the final render because it just took too long.
Over an hour.
It was over an hour. And by that point, we were like, the other ones are going to do way better.
Yeah.
So then we went to the garbage build version 2.
Garbage 2 was like, let's throw out these processors. I could not find 2 V2 processors, so we only did it with one, figuring that, well, if it scales well with a lot of processors, we could throw in another processor. We know what the performance is going to be if we know what the performance is, kind of, sort of, with the 2680 V2. And it's 10 cores, 20 threads, so it's like the i9, except instead of being $1,000, it's $150.
Right. That was what excited me about that processor.
64 gigs of RAM, 10 core. The motherboard will cost you, but sometimes you can get a surplus motherboard, which is what this was.
So that ended up generating a proxy clip in 1 minute and 19 seconds, which is about a minute faster than the previous test that we did.
So we went from 24 threads to 20 threads, and it's that much faster.
Right. That was across 2 CPUs in the other one.
Yeah.
For render time, it took 20 minutes and 57 seconds.
Not great, but not terrible, considering the cost of the machine. And, you think about RAM prices and ECC, 64 gigs of memory on that platform, it's a couple $100 versus $1,200 on DDR4 at current prices as of the time of this video.
So we then tried the i7.
That's the 8700K that goes up to 4.5 gigahertz. A lot of the mantra on the internet is things that don't parallelize really well will benefit from that ridiculous clock speed because it's 6 cores, 12 threads.
This actually performed better than the previous one. We ended up with a minute-long transcode time.
Not bad.
Yeah, 19 seconds faster, I think. The render time, though, was 27 minutes and 32 seconds.
Not great, but not terrible.
It was, that was a nice build. It was water cooled, so it didn't put off a lot of heat. I like that. Let's see. The i9 was the next build that we tried. It was 51 seconds for generating a proxy clip. That was cool. And then once we got the turboing working, it took 14 minutes and 56 seconds.
Almost 15 minutes, which is not bad for 10 cores and 20 threads.
Yeah.
And that's how much of a performance improvement you can see versus the 2680. Now, the 2680 tops out at 3.5 gigahertz, so we're talking about a full gigahertz faster per core across 10 cores. in the sky, 4.5 gigahertz with the 7900X, which is a mild overclock. Well, not a mild, it's middle of the road overclock. Now, the comparison wouldn't be complete if we didn't also test Ryzen 7. So Ryzen 7 1700X, basically its stock configuration with a stock cooler.
This one was surprising to me. I really...
Would you say it was surprising?
Surprising! Oh, that's good, dude.
No, that's really bad. It's really terrible.
So this was rather comparable in transcode time. It was 1 minute and 1 second.
So almost, not quite margin of error, a little slower.
Yeah, just barely slower. How many cores are in this?
8. 8 cores, 16 threads.
Yeah, so that's pretty good, I'd say. Render time took 20 minutes and 55 seconds.
That's still pretty good compared to the landscape of the other machines that we have. I mean, when you consider that you can get the 1700X processor for around $300 versus the $1,000 that the 7900X will cost you.
Yeah.
It's, those extra 5 minutes is not too bad. 6 minutes, I guess. Actually.
Technically, check your math. So Threadripper 12 core.
Yeah, Threadripper 12 core was a lot of fun to test.
Yeah, this one didn't actually finish because MLT crashed while we were trying to render, but it was able to transcode at 52 seconds, which was pretty impressive. That was one of the fastest times up to that point. And then we tried the 16-core configuration, and that was 49 seconds for a proxy clip and 17 seconds to render the video.
Or 17 minutes.
17 minutes, 33 seconds to render the video.
Not bad.
Yeah.
So Threadripper is not, Kdenlive not super parallelizable. Looks like I guess the i9 was technically the fastest with the 4.5 gigahertz clock speed.
Yeah.
But even beyond 8 cores, the transcode does not seem to take advantage of multiple cores, because we were watching the clock speed trying to figure out what was going on with Threadripper, and it was not super easy to figure out what the heck Kdenlive was doing.
Yeah.
But the good news is that while Kdenlive was doing that, it was entirely possible to play Rocket League or Civ or do benchmarks or whatever, because it just couldn't use all the resources on the machine for whatever reason.
Yeah. And that's something I've run into with my system at home, and that's kind of why I wanted to do these tests, to find a better solution.
Now, the next thing we needed to test was graphics cards, so we wanted to kind of separate things out a little bit. Now, Kdenlive does have video acceleration, of course, but we were more interested in the video card from like a gaming aspect. And I've done a lot of work with Vega. I've done a lot of work with Vega for the Looking Glass project, and not just Vega. I mean, 1080 and everything else. And so I know that the Vega drivers are not exactly stable yet on Linux, but they've come a long way, especially with kernel 4.15. So we souped up your Ubuntu 17.10 with the very, very latest version that we could get our hands on with patches, 4.15. Also deployed the latest LLVM and Mesa. And we did all sorts of unholy sacrifices, blood sacrifices, and it was not a pretty experience. But we did get Vega 64 up and running, and so we could do a lot of game benchmarking. Now, throwing into the mix, we also tested a GTX 1080 as well as a Strix Fury. We tested the Asus Strix Fury because it's the R9, the Fury, not the Fury X, because the non-Fury X wasn't even going to be a thing, and then Sapphire and Asus, and I think that's it. Just used sort of a cut down version of the Fury X with air cooling, and so we did testing with that, and the results from that were kind of shocking.
Yeah. One of the things that was most noticeable with the recorded footage, but was not noticeable while actually doing the benchmarks, was the color depth. And I thought that the GTX 1080 actually had the best looking of all the colors in the footage. We ended up using my AverMedia Live Gamer Portable 2 to capture all the footage, so it wasn't any kind of performance penalty for recording footage. So one of the things that was really cool was that Bioshock Infinite had such a dramatic difference between the 1080 and the Fury.
Yeah.
I think the maturity of the open source driver really shows, because the R9 Fury outperformed the 1080 in most cases, and I thought that was really cool.
Yeah, we were using the DC =1, sort of the next generation DC pipeline on the Fury, which is not enabled by default on the kernel 4.15 on the Linux side of things, and I was really expecting Vega 64 to be a lot faster, but it's not yet, and I think that's probably owing to the experimental nature of the extensions on those drivers for Vega 64. I'm not really precisely sure. I mean, that's really just a guess. But I was expecting Vega 64 to be faster. And from the testing that I did a long time ago, well, it's probably been about a month and a half, 2 months ago, the Vega 64 setup was running a lot slower than it was even just 6 weeks ago, 7 weeks ago. And I'm not sure if that's differences between Fedora and Ubuntu, or if that is changes in the driver, or maybe I didn't get something exactly right with the Mesa setup or something like that. We'll probably investigate that and try to figure it out. But it's also really promising because if they've been able to do what they've been able to do with Fury over its lifetime, assuming that the development goes into Vega 64, then, you know, it will be at least that good. But as of right now today, Vega 64 is at least as good as the Strix Fury and is on par with the 1080.
Yeah.
At least the binary blobs under Linux.
Right. The thing about the Vega 64 was that the performance it had like dramatic differences in frame rate. I mean, within a couple minutes, you'd have 30 frames a second, and then you get up to like 200 or 300 frames a second.
Yeah, I want more of the 200, less of the 30.
Right.
That's kind of what I was experiencing with Civ. So I did a video a while back where Civ was running at just ungodly speeds sometimes with Vega 64, and there was a lot of visual glitching and stuff going on, and it's like, well, maybe it's mostly running right. And now with the current versions of the driver, most of the visual glitches have been fixed. The performance has suffered, and there's still a lot of visual glitching.
Yeah. I would say it's pretty unplayable with the glitching that it has, but
interestingly, Bioshock and the other games are unaffected.
Yeah, that was interesting. I was expecting to see more visual glitches with.
I think we also tried to benchmark Serious Sam BFE, but it kept hanging with that driver version as well. So, this is clearly not quite a finished product. Here's hoping that AMD can find the right developers and engage them to get things lined out, because there are dozens of us, literally dozens of us.
So, all in all, I think I'm leaning more towards Team Red, based on the performance of the R9 and the fact that you can use open source drivers, because Navu just can't keep up with.
Yeah. Well, and consider look at the performance improvements on NVIDIA with their binary blob the last year. I mean, it's there. They've updated the driver. I don't want to fault them for that.
Yeah.
But I think that AMD has come a lot farther in a lot less time with a lot less resources.
I would agree with that.
So hopefully they'll overtake it and catch up and stuff like that. This has been a fun project. We should do this again.
Yeah.
So if you enjoyed this, definitely do give us a thumbs up. Or if we've erred fatally, made the wrong joke or something, I guess you could thumbs down. I mean, that's fine. And don't forget to engage with the comments, because that's a thing the algorithm does now, and we have to be kind to our machine overlords. Otherwise, they punish us. You should also check out his channel, which is in the description, because engagement.
Yeah, that'd be nice. Engage with my channel, maybe a little bit.
What if anybody finds the giant cartoon penguin off-putting? Just staring at them the whole video, unblinking.
I wonder how many people didn't notice until you said something.